In this, we are seeing the 3-port bidirectional converter for charging and discharging of the battery for electric vehicles with grid to vehicle and vehicle to grid power flow capability. The simulation circuit is provided here. In this, from the PV panel, it is provided to the battery and also to the DC bus. And when PV is not available, at the time the battery will provide the supply to the DC bus. In PV, some reduced power is there. That power combined with the battery will be providing to the DC bus. When PV is not available and when battery is also not available, at the time from DC bus, the power flow will be reversed. That is grid to vehicle and vehicle to grid. In for this, three loops are there. One is MPPT control based voltage control, that is for PV applications. Here from the PV, voltage and current is measured and given to the P&O based algorithm. From that, reference power is generated, that is divided by the voltage to get the reference current, that is compared with the measured PV current. Error is given to PI controller. The PI controller will generate the duty ratio here. Similarly, for DC bus voltage control, this controller is used. 48 is the reference voltage and measured voltage is provided here. Error is given to PI controller. PI controller will generate the duty ratio here. And this is battery voltage control. In this, battery voltage is 36 and it is compared with the measured voltage. Error is given to the PI controller. The PI controller will generate duty ratio. So depending upon the mode conditions, here these duty ratios will be assigned for the pulse generation and given to the respective switches. In this, initially from PV to vehicle and grid, that is PV to battery and the DC bus, and then PV to grid, and then PV to vehicle and grid, and then PV to grid, and then vehicle to grid. After 1.25 seconds, vehicle to grid until 1.65 seconds. And here after 1.65 seconds, grid to vehicle. Okay, all the modes are provided. That is depending upon the battery SOC and power availability from the PV. Here I have connected the battery of 90%, 95% from 0 to 0.33 second. From 0.33 to 0.66 second, the battery of 55% SOC is connected. After 0.366 seconds to 1 second, battery of 20% is connected. So these three batteries will be connected alternatively for each 0.33 second. And here irradiation, initially it is around 1000 watt per meter square, and after 1 second it is reduced to 600 watt per meter square, and after 1.25 seconds it is reduced to 0. So according to that the power will be varied, and according to that the modes will be selected. Here this is the DC bus voltage and current value. DC bus voltage and current depending upon PV to vehicle and grid, PV and vehicle to grid, PV to grid, like that for different modes, vehicle to grid, grid to vehicle. For different modes, different current value is provided. And here, state of charge of the 95 percentage charge battery. Here in this, if you see, means initially the battery will be charging under PV to vehicle and grid mode, and here under vehicle to grid condition the SOC is reduced. Similarly, when 55 percentage SOC battery is connected, okay, initially the battery will be disconnected, and after that it is same, and after 1.3 seconds the battery SOC is reducing here. Similarly, in this, from PV to vehicle and grid the SOC increases, and again it is constant, and from grid to vehicle condition the SOC increases. So these different batteries will be connected at different times, and based on that battery selection or battery SOC, and based on the PV power generated, the modes will change. If the PV is providing sufficient power, means there is maximum power, means here the battery will be charged along with the power flow will be to DC grid. When the power is reduced here, this PV power plus battery power will be combined to provide it to the DC bus. And when PV is not available, from vehicle to grid, the condition is flowing. And when PV is not available and the battery SOC is very less, at the time from grid to vehicle the power flow is continued. So this is a single converter with three ports. One port is for PV, one port is for battery, that is EV vehicles, one port is for DC bus or DC grid. Here we are using four switches. Based on these four switches, the modes of operation differs. So this is the working of the multiple port converter for EV applications with PV source.